Almost all elements can combine with mercury to form an alloy in a process known as amalgamation. For this video though, I'm going to be focusing on its interaction with gold, and to do this, I bought some gold leaf off Amazon. I cut out one of the pages, put it in a bowl, and then I start to add the mercury. I was honestly surprised with what happened, and I thought the mercury was just going to dissolve the gold where it landed and make a hole in the leaf. I think if I just put one large drop, it would have pulled the entire leaf in, but because I used multiple drops, they kind of started battling and eventually ended up in a stalemate. I tried to speed things up by adding several more drops, which initially seemed to work, but it quickly slowed down again. I think if I let it sit here for something like an hour or so, all of the gold would eventually be pulled in, but I was a little bit impatient, so I kind of just pushed everything together. There was still a decent amount of gold left, but I rolled it around for about 30 seconds, and most of it disappeared. On a quick side note, this is why when you're working with mercury, you really need to be careful with your gold jewelry. Anyway, I decided to add a page of gold leaf to this blob, and this time it was much faster and, in my opinion, a lot cooler. One thing I should mention though is that this effect is a little bit exaggerated because the gold leaf has a super high surface area. A solid gold chunk will still amalgamate, but it won't be nearly as spectacular, and it actually is kind of boring to look at. Anyway, I was so amused with it, I did it 23 more times with every other gold leaf that I had. As more is added, there's less and less free mercury to amalgamate the gold, so the rate slows down. The first foil that I added disappeared in less than 10 seconds, but this is the 16th one, and it takes about 30. Also, because the mercury gold amalgam is a solid, the blob will thicken as more gold is added. I'm going to be covering this in a future video, but this is kind of how dental amalgams are made. Instead of using gold, dentists use silver and some other metals like tin and copper to make this pasty metal material which can be used to fill teeth. Anyway, after adding all the gold, I was left with this really dense blob. It's solid enough that I can squish it together like clay and try to mold something. I'm not really sure how to describe how it felt, but it had a bunch of excess, unamalgamated mercury in it, so it was kind of a mix between a solid and a liquid. When I squished it, it shot out a bunch of mercury. To get rid of the rest of the liquid mercury, I cut out a square from one of my socks. The mercury gold amalgam is a solid so it stays in the sock, but with a little bit of effort, the excess liquid mercury can be squished through. The mercury gold amalgam that I have now is much more solid. However, unlike the silver amalgam that's used in dentistry, as far as I know, the gold amalgam doesn't have much use on its own. What's more important is the actual process of the gold amalgamation, which is used to refine and purify gold. On a large industrial scale, most developed nations have turned to more environmentally friendly and safe methods, but on the small scale, this is still really useful. The basic idea is to crush up gold-rich ore into as fine powder as possible, and then to mix it with mercury. The mercury will leach out the gold and either just become highly concentrated, or it will form some solid amalgam chunks. The gold is then isolated either by boiling off the mercury or by chemical treatment. In this shot here, I'm adding the gold amalgam to a little bit of concentrated nitric acid. The nitric acid reacts with the mercury and dissolves it into solution, but it doesn't touch the gold. The reaction is a little bit slow, so I occasionally blasted it with a heat gun and mixed it around. This process isn't exactly environmentally friendly or safe, and it lets off a lot of nitrogen dioxide gas. Eventually it's done reacting, and I have a whole bunch of powdered gold at the bottom. The nitric acid, which has mercury salts in it, is poured off, and the gold is washed a few times with distilled water. I put the entire vial in a toaster to dry out the gold, and then I transferred it to a smaller one. The total mass here is 0.25 grams, and I put in 25 pages of gold leaf, so it means that each one is about 0.01 grams. This is quite a small amount, and it's only worth about $11 US. I decided to keep the gold as a powder, but it is possible to melt it down into a small button. As a powder, it's very finely dispersed and not shiny, but once we melt it down, it will become shiny again. Anyway, I think that's about it. For those of you who follow me, you'll know that this video is a lot shorter than my regular one, and I think I'm going to continue posting more like this. This isn't going to be a replacement or anything for my longer ones, and I'll still be putting out about 4 of those per month.